So to kind of overview my presentation, we're going to kind of talk about what is hydroelectric power, and also sort of what role does it play in our society today. And then we're also going to talk about how it's produced, and then some of the thermodynamic topics that kind of apply to hydroelectric power and how it's generated. And then some of the advantages and disadvantages versus other power sources. So basically, hydroelectric power is power that's produced from flowing water, and it's basically taking potential energy out of that water. So we're going to see a little bit later on, talking about where that potential energy is, how it's created. But as far as globally, as of 2006, I believe that number is correct, it's 19% of total global electricity production is from hydroelectric power, or it's produced from water. And so it's also one of the lowest methods of producing power, going way back when they didn't have advanced technology that we have today and all the access to different fuels that we have today. So basically how power is generated, off to the right over here we have a upper reservoir, off to the left we have the lower reservoir. And so on the right there's going to be a height difference between these two reservoirs, and that's where our potential difference is going to come in. So that's the potential energy that we're trying to get out of the water. And so we can actually control how much of that water comes through. And this is looking at a dam. And so how much of that water is going to come through, and that's going to actually rotate a turbine. And that turbine is connected to a generator, which is how we're going to get the power from the water. And that's going to flow into the lower reservoir. And with the technology that we have today, they actually have something called pump storage. Where it basically uses a submersible pump, and that's going to pump the water from the lower reservoir back up to the upper reservoir, so we can use it later on and use it again. So this is a diagram of the turbine and the generator. So you can see the water flowing into the turbine. That's what's going to cause rotation of the turbine, which is going to rotate our generator, and that's normally connected to a power plant somewhere that's not very far away. And then the water comes out of the turbine, and that's going to go into our lower reservoir. So basically the first law of thermodynamics, looking at that for this, we have our change in internal energy. If we just look at a specific volume or control volume of water, we have the only change in internal energy is going to be coming out of the potential energy, which is the change in that, the change in height. So that potential energy is going to do work, and that work out is what's being done by the turbine. That's where the work's taking place. And then it flows into a lower reservoir. And so then we can pump that water back, like I said earlier, and use it in the upper reservoir to regain that potential energy. As far as the available power that's in the water, we have the density of water times our gravity, and that height multiplied by the volume flow rate, as well as the K is a efficiency factor. That's going to be the efficiency of the turbine, generally between 0 and 1. In recent times, that's actually gone up closer to 1. So that's one thing that they're actually kind of working towards. But the variables, what I have down here is noted that the variables greatly depend on nature. Your rho is going to stay fairly constant because there's not, as far as the change in elevations, there's not a drastic change in your density. But your height greatly depends on precipitation and what the location is of those reservoirs. Some of the advantages for hydroelectric power would be that it reduces the CO2 emissions. That's relative to combusting fuel. And then it's also a free renewable energy source. So it's naturally occurring, and we don't really have to go very far to get it. And then there's low operation costs and maintenance costs versus burning fuel or combusting gas. And then available to developing countries. So it can be used, it's available in relatively small size. That's what I have pictured here. Generally we think of like giant dams, which cost a lot of money to construct, which is actually one of the disadvantages. But you can use a relatively small sort of scale it down, and that can produce less power, but over developing countries they don't have as much that they need to power like we do here. And so some of the disadvantages is that it does require high investment in construction. The risk of failure is that the construction of a dam is very important because a poor construction gets magnified over that scale. very dependent